Hi, everybody. Hope you've had a good day. I'm Madeline Beckham, and this is my video on the Bernoulli principle. To start off, let's look at Daniel Bernoulli's past. Who was he? Well, he was born in Groningen in the Netherlands on February 8, 1700. Johann Bernoulli and Dorothea Faulkner were his parents. His father, Johann Bernoulli, was a doctor and mathematician from Basel, Switzerland. He worked to expand the knowledge of calculus, which was then a new kind of math. Johann Bernoulli's nickname was Archimedes of the age because he was so famous and intelligent. This is a picture of Johann Bernoulli, Daniel Bernoulli's father. When Daniel was only 5, the family moved to Basel, Switzerland, where the parents had grown up. This was in 1705. Johann Bernoulli got a job at Basel University. But he was bitter because of the low pay he was getting, so he pressured his son Daniel to take the family back to their former wealth and fame. The whole Bernoulli family were geniuses. Daniel Bernoulli's 2 brothers became mathematicians, and Daniel excelled in school. He learned about math and physics from his father, and he went to several schools to learn about other subjects. Daniel graduated in 1721. He was 21 years old. After failing to find work in his hometown due to a bizarre selection process at a university he wished to work at, he had to move to Venice, Italy, and study mathematics. This is a picture of Daniel Bernoulli. In 1724, Daniel Bernoulli published his first book, called Mathematical Exercises. Later that year, he became a professor of physiology at the Academy of Sciences in St. Petersburg, Russia. He was only 24 when this happened. He traveled to Russia with his brother Nicholas, who had also been given a professorship for math at the same school. A year after they got to Russia, however, Nicholas died with a fever. Johann Bernoulli, Daniel's father, attempted to comfort him by sending a very successful math pupil, Leonard Euler, to study with him. He knew that Daniel would like this company. Leonard and Daniel were both very smart men, but working together they were a perfect team. In 1738, Bernoulli published Hydrodynamica, his most famous work. He was 38 years old. Daniel Bernoulli died on March 17, 1782. He had never married, but he was one of the greatest scientists ever. So what is the Bernoulli principle? The Bernoulli principle is one of the things that Daniel Bernoulli developed and put in his book, Hydrodynamica. The principle says that as the speed of a moving fluid, which could be a liquid or a gas, increases, the pressure within the fluid decreases. So basically, as a speed or as a fluid, a liquid or a gas moves faster, the pressure goes smaller. For instance, when air is moving fast between 2 objects, the air pressure in the air decreases and causes the objects to be sucked together. Here's an example of the Bernoulli principle shown in real life.
Hello. Today I'll be doing an experiment that demonstrates the Bernoulli principle. We need some straws and 2 cans. First we take out a straw, any color. I like the pink. Next, you get the 2 cans and you put them about 1/2 inch apart. Next, you get the straw and you put it kind of in between the cans, and then you blow. That's all I have for you today.
Wow, what just happened? What happened to the cans when I blew in between them? Let's watch it again and see.
In between the cans, and then you blow.
The cans drew together. Why is that? In the video, you could see that when I blew in between the cans drew together. The air I blew in between the cans was moving fast, so according to the principle, the air pressure in the air between the cans would decrease as the air moves faster and cause the space between the objects to go away and suck the objects together. Here are some examples in real life of how the Bernoulli principle is still valid today. Example 1. Air flight. The Bernoulli principle was obviously taken into account when designing airplane wings. It's because of the Bernoulli principle that we can fly in airplanes today. When you look at the wing diagram right here, you can see that the top of the wing is curved, while the bottom is completely flat. Because of this, the air passing by the top moves faster, making less pressure, and the air on the bottom moves slower, which makes more pressure at the bottom. This is what makes the airplane fly. When the air moves faster this way, over this side of the wing, the air pressure decreases, just like it says in the Bernoulli principle. This causes a principle called lift, which makes the airplane able to fly. Example 2. A draft from an open door. When you're in a room with the door closed and you're hot, you want to open a window, right? But when you do, why doesn't the room cool off right away? Because of the Bernoulli principle. The closed door is the point in the room where all of the hot air pressure is gathering. When you open the window, this hot air pressure point doesn't change, so not much cold air is able to come in because the hot air isn't escaping. But when you open the door, all the heat that's been gathering up can fly out, and the cold air has a place to come in, making the room cold and making you feel a draft. Example 3. Two ships passing each other. Have you ever seen two ships pass each other in the ocean? When two ships pass each other, they have to give each other a very wide berth. The reason is because of the Bernoulli principle. If the ships were to pass too closely together, then they would be sucked together and crash because they would be going fast and the air pressure between them would decrease. Here's a picture of two ships that did not give each other a wide enough berth and crashed. Here are the sources from which I got all my information: www.famousscientist.org, bernoullisprinciple.weebly.com, and www.infoplease.com/encyclopedia. I hope this video helped you understand the Bernoulli principle more and realize how we can relate it to real life today. Thanks for watching. Goodbye.